एक सेकंड होल्ड करें, एडमिट कर लें। Okay, today we are going to discuss about the heat transfer mechanisms in different states of the solids, like in the solid state, gaseous state, and that of the
Hello.
सर आवाज बंद हो गई है।
अच्छा, अब आ रही है?
Yes, sir.
Yes, sir.
Actually, what I was doing, I was basically muting all the participants, and in that scenario, I muted myself. Okay, so there are three mechanisms by which heat can be transferred, and you already have studied in your FSC that those three mechanisms are conduction, convection, and radiation. Now, depending upon the type of the phase by which it happens, मतलब conduction occurs only in the solids. ठीक है? And how does conduction occurs? कैसे? How the
Sir,
transfer
मतलब
of heat takes place?
hot particles मतलब low जो मतलब cold particles की तरफ ट्रांसफर करते हैं.
And how they transfer it?
Through vibration.
Vibration. And why
of
they?
mass.
Sorry, what you said, बेटा? Last जो student है, क्या कहा है?
Through
Movement
vibration.
of mass.
Mass. Okay. चले मुझे ये बताइए कि why this starts vibrating? मतलब it is just repetition of previous concepts. Why they start vibrating?
Sir, क्योंकि उनकी kinetic energy काफी ज़्यादा होती है, जब heat ज़्यादा होती है body पे.
Okay, so then why the end that is near to the hot, or you can say near the fire is more hotter compared to the other end of the rod? मतलब if let's suppose if you are hitting the rod, so the one end is near to the fire and other end is the away from the fire. So why the end that is near to the fire is more hotter compared to the other end?
Sir, क्योंकि उसका डायरेक्ट कांटेक्ट है फायर के साथ, जो कि मतलब हाई टेम्परेचर है, और वो जो दूसरी साइड है रॉड की, वो कांटेक्ट में नहीं है, इसलिए उसका कोल्ड है टेम्परेचर.
तो मेरे ख्याल में there should not be मतलब there should not be any heat in that scenario.
सर वो कैसे?
क्या कहते हैं? Because they are not near the heat. क्यों, यही बात नहीं है?
ज़्यादा टेम्परेचर की वजह से जो मेटल के एटम्स हैं उनकी वाइब्रेशन और काइनेटिक एनर्जी बढ़.
Actual में जो the only thing that is happening there is कि the atoms are that are near to the fire initially, that are the only source of the heat transfer within the rod. Okay, now these atoms start vibrating as you talked earlier or told earlier, that these starts vibrating. Okay, now greater is the energy, greater would be the vibration. So we studied earlier that when you will heat the metal or something like that, so the atom was vibrating. Greater is the energy, greater would be the vibration. Okay, so when they will start vibrating about their main position, so what will happen, that they will strike with the neighboring atom. So once they will strike with the neighboring atom, they will transfer their energy. It is just like blade ball. स्नूकर कौन कौन खेलता है आप में से? ऑलमोस्ट एवरीवन नो अबाउट दिस स्नूकर. ठीक है?
Yes, sir.
So मैंने नहीं खेली हुई, मुझे तो ये भी नहीं पता कि व्हाट वी यूजुअली कॉल द व्हाइट बॉल और क्या हम दूसरे बॉल्स को कहते हैं, बट एनी हाउ in the videos or something like that we have seen that the player basically strikes the white ball, ठीक है, it strikes with the other ball and the white ball stops or its energy or its velocity reduces. So what is happening there? It is transferring its momentum from itself to the other body. So just like that, we will call white ball as the first atom that is getting heated up and it starts vibrating. When it start vibrate, it will collide with the neighboring atom. So it will transfer its energy to the neighboring atom. In this way, neighboring atom will start vibrating. In the meanwhile, the energy of the first atom will get reduced because it has transferred its energy. But since we are consistently giving it heat or we are consistently heating it, so what is happening? It will gain its energy again and it will again strike. In this way, chain process will start on and it will go up to the other end depending upon the time. Matlab, if you are hitting for a quite lot of time, if you have 1 meter length, it will hit it up. If you are hitting for very small time, so obviously heat will not reach to the other end of the rod. So it's all depend upon the time, heat transfer, temperature, and all these parameters. So all these things happens in the solid spaces. Okay. When you have a solid, and if anyone asks you, okay, what is the mechanism by which it is transferring? The straightaway answer is conduction. Conduction is the process that is transferring. So why we need to? Okay, we do know okay, conduction is taking place and something like that. So what would be its importance? Kaise? Why we need to study it? What sort of the importance or the application it will have? Anyone? ठीक है, कहने को आपने सारों ने बता दिया. You already studied in FSC. We usually deal it in our daily life, but what is it importance? ठीक है, okay, I do know कि solids में जो है, especially metals, they will transfer heat more quickly. Then all the things we already know, then why we are studying it and what would be its importance if we will study right now?
सर मेरे ख्याल में जो हम कुकिंग करते हैं उसमें शायद कंडक्शन होती है, पॉट वगैरह.
वो तो ऑलरेडी है, हमें पता है, यूटेंसिल्स में भी होती है, ठीक है, हो रही है. ओके फाइन. देन अदर देन दैट
सर वो मास एनर्जी को एक्सप्लेन करता है.
सॉरी बेटा, मैं समझ नहीं आई, क्या कहा आपने?
सर मास एनर्जी रिलेशन को एक्सप्लेन करता है कंडक्शन.
मतलब टू सम एक्सटेंट, मतलब इसको हम इतना सीरियसली ले नहीं सकते, ठीक है. अदर देन दैट
सर वो वार्म एयर, कोल्ड एयर, वो जो साइकिल टाइप है वो भी है.
अच्छा, एक्चुअल में मतलब इन थर्मोडायनेमिक्स तो मैंने जब आपको ड्यूरिंग फर्स्ट लेक्चर, इंट्रोडक्टरी लेक्चर में मैंने बताया था कि इट हैज एप्लीकेशंस इन एवरी लाइफ, मतलब एवरी एस्पेक्ट ऑफ द लाइफ, ठीक है. तो सिंपल इज दैट, द सिंपल आंसर इज दैट व्हेन यू यूज ए पॉट, ठीक है, यूटेंसिल यूज करते हैं फॉर द प्रिपरेशन ऑफ द टी. आप लोगों ने अक्सर ऑब्जर्व किया होगा, और यू कैन से कि आप जब कोई प्रेशर कुकर यूज कर रहे होते हैं, दी अदर एंड ऑफ द, या दी फॉर एंड जो है, या दी एंड दैट फ्रॉम विच यू होल्ड द पॉट और द कुकर, इट इज बेसिकली ऑफ डिफरेंट मटेरियल, ठीक है. यही नहीं होता, मतलब इन मोस्ट केसेस इट इज वुड और प्लास्टिक. सो मेटल इज अटैच, मतलब द हैंडल इज wrapped with the plastic or a wooden plank, something like that, ठीक है. So what is happening there? The conduction of the wood or the plastic is very, मतलब they are poor conductors, so obviously they will not transfer the heat. On the other end, क्या होता है कि if you will see that in the thermal insulations of the homes or the other materials, ठीक है, we use the thermal insulators or poor conductors. Have you seen the fridge internally? कभी किसी कबाड़िए के पास आप लोगों ने देखा हो फ्रिज खुला हो, या if you have seen the thermos or if you have seen the cooler, water cooler, ठीक है, जो मतलब घरों में यूज करते हैं, कि ओपनली हो, मतलब from the inside you have cross sectional view में कहीं देखा
फोम इंसर्टेड होता है,
येलो सी फॉर्म होती है, येलो फॉर्म.
हाँ बिल्कुल इसी तरह. And why they are using
Insulation, thermal
Thermal
insulation.
insulation.
Thermal insulation.
That's the thing.
Insulation
in
के
the
लिए।
बिल्कुल in the case of the water cooler, ठीक है, in order to keep the water cold in the summers, ठीक है, for the geyser we basically want to avoid the transfer of the heat to the atmosphere from the water. So for that purpose we are using that thermal insulator. Now that thermal insulator is basically a poor thermal conductor, so it will not let the heat in or out. So let's suppose हम गीजर की बात करते हैं. In the case of the geyser in the winters क्या होगा? In obviously the outer atmosphere has the lower temperature, so heat will transfer from the geyser to the outer atmosphere. So this thermal insulator basically avoids that transfer of heat. And normally, if you want to make the geyser more efficient, you can also wrap the another foam around the body. ठीक है, आप मजीद wrap करेंगे, what will happen that it will make it more insulator. ठीक है. Now coming toward the buildings.
सर ये इंडस्ट्रीज में भी तो लगा होता है रिएक्टर्स के थर्मल इंसुलेशन
बिल्कुल जी, इसी तरह बेटा ये हर जगह पे लगा होता है. ये किसी का माइक ऑन है बेटा, काइंडली ऑफ कर लें. अली का था. एक सेकंड बेटा, ये अली अच्छा यार, मैंने अपने आप को म्यूट कर लिया था अली को करते करते, सॉरी. अच्छा, एनी वन ऑफ you have visited the old buildings, Mughal era buildings? Any one of you?
Yes, sir.
Even if you have seen the old buildings at your villages, but the very old buildings, I am talking about 50 years ago, yeah, 100 years ago, the buildings that have been built, ठीक है, 100 years. So if you will see that their walls are quite thick, very thick. मतलब आप ये देखेंगे कि देयर वॉल्स आर क्वाइट थिक. मतलब हम नॉर्मली क्या होता है कि बहुत स्मॉल वॉल 2 ईंटों की होगी वॉल या 3 ईंटों की. तो इफ यू विल सी दैट दे हैव ए क्वाइट बिगर वॉल्स, ठीक है, अगेन, एंड दे वर यूजिंग
क्ले,
मतलब एक मतलब मट्टी यूज करते थे, और दे वर यूजिंग जिप्सम टाइम, समथिंग लाइक दैट. के basically those two things are made the house thermal thermally. They were basically thermal insulators. Even now, if you will build a house with a clay, ठीक है, क्या होगा, that house will be more colder in summer compared to the brick houses which we are using, or they will be more warmer in the winter compared to the houses in which we are living. ठीक है. So these two things are basically thermal insulators, and they build their buildings on the base of these two things. ठीक है. अच्छा, now the problem with us is that the clay buildings are not that much strong compared to concrete buildings. So this is the main reason that right now we are building, these are sort of the buildings in which we are using the bricks here. So the end discussion about all this, मतलब कह लें कि end result of all this discussion is कि the conduction rate, or you can say कि the conduction of the heat depends upon certain parameters. It depends upon the time, it depends upon the thickness of the material, it depends upon the surface area. It is just like if you have a hot reservoir of a water, yeah, if you are you have boiling water, ठीक है, in a pan, and if you will, for just very small instant, if you will touch your finger, क्या होगा? you will not feel that much heat. यही होता है ना कि suddenly if you are एक finger just you are touching the finger to the surface, ठीक है, very instantly, मतलब microsecond कह लें या 0.1 millisecond कह लें, ठीक है, and you will see that you are not feeling that much heat. On the other hand, वही पानी हो and if you are placing your finger for a quite some time, 1 second, 2 seconds, 3 seconds, you will your finger will burn down. यही नहीं होता?
Yes.
जी सर।
So it means कि क्या है कि ये आपकी टाइमिंग पे डिपेंड कर रहा होता है, ठीक है, ऑब्वियसली मतलब कांस्टेंट ही है, ठीक है, हमारी सारी टेम्परेचर डिफरेंस तो इट इज कांस्टेंट, बट इट इज आल्सो डिपेंडिंग अपॉन द टाइम ड्यूरिंग विच टाइम ऑफ द कांटेक्ट, ठीक है, आल्सो इट डिपेंड्स अपॉन द एरिया of the contact. Greater is the area, greater would be the transfer of the heat energy. Smaller is the area, smaller would be the transfer of heat energy. So all these things, ठीक है, depends upon the basically define the conduction rate. So normally when we use the materials or when we basically want to use certain material, we basically find its conduction rate, whether it has a good conduction rate or it has a bad conduction rate, ठीक है. So this conduction rate is, that is heat energy transfer per unit time given by 1832 equation, is directly proportional to the thermal conductivity. Greater is the thermal conductivity, obviously greater would be the conduction rate, and it is also directly proportional to the area. Greater would be the area, greater would be the conduction rate. Again, if area is larger, means that more energy will be transferred in a short time, okay. Then it is dependent upon the temperature difference and the thickness of the material, okay. And how he has explained, how he deducted this equation, he is basically telling us that you have here, just hold on a second,
इक्वेशन को दोबारा बता दीजिएगा।
जी मैं बताता हूँ बेटा। This is the slab here, मतलब this blue color is the slab here, ठीक है। ये नजर आ रही है आपको फिगर 18 में मैंने एरो लगाया, आर यू गेटिंग दिस?
Yes sir.
ठीक है। So this is the slab here, which has a thermal conductivity of K, which has the thickness of L, and it is on the one hand, on the left hand side, it is connected to a hot reservoir. On the right hand side, it is connected to a cold reservoir. So energy is transferring through this slab. So the conduction rate is dependent upon conduction rate is dependent upon different parameters. So this equation, which is equation 32, so this conduction rate is dependent upon what parameters? First of all, they mentioned that conduction rate is directly dependent upon the thermal conductivity. So if this slab has a greater thermal conductivity, what do you know? What do you think that what would be the conduction rate? Whether it will more heat will be transferred per unit time or less heat will be transferred per unit time if it has a larger thermal conductivity?
More heat transfer.
More heat will be transferred. Obviously, in less time, more heat will be transferred. Secondly, he is saying कि area of, अब this is the area, मतलब the face that is attached to the cold reservoir and the area that is attached to the hot reservoir, ठीक है। अच्छा मजे की बात ये है कि चलें छोड़े, मैं नहीं करना चाह रहा, बच्चों वाले करते हैं कि स्टूडेंट। अच्छा द सेकंड थिंग इज के एरिया, दिस एरिया, ठीक है, कि ये एरिया जो है आपका, greater is the area, greater would be the conduction rate or greater would be the heat transferred, ठीक है। So it is again directly, conduction rate is directly dependent upon the area, ठीक है, that is exposed to the atmosphere or something like that. Then it is also directly proportional to the difference in the temperature, ठीक है। Greater is the difference, greater would be the heat transfer or the conduction rate, ठीक है। And at the end, it is inversely proportional to the thickness. If you are using more thicker material, obviously less heat will be transferred, ठीक है। If you are if your house walls are thick, ठीक है, they have more width compared to the normal walls, less heat will be transferred, ठीक है. So this is the question that describes the conduction rate here. So is it clear, beta? Any question up to this point?
नहीं सर, क्लियर.
Okay, बेटा. चलिए, now coming toward the, अब इन्हीं चीजों को यूज करते हुए we will go for the other things. ठीक है. अच्छा, normally we do not deal with the thermal conductivity when we basically specify the materials as insulators, heat insulators. We basically deal with the quantity or the parameter that basically deals with the thermal insulator is the thermal resistance. ठीक है, R value. R value basically describes the whether this material is a thermal insulator. If some material has a high R value, it means that it has high thermal resistance. If any material is a good conductor, it will have low R value. So this R value is basically dependent directly on the thickness and is inversely proportional to the thermal conductivity. So you can see here that if we are using good thermal conductor, क्या होगा? Its K value will be high. So if K value is high, so it means its R value will be small. Means that its thermal resistance will be small for a good conductor. On the other hand, if you are using a good insulator or poor thermal conductor, the K value or the thermal conductivity of the material will be small. So as a result, the value of R will be large. So it means that it is good insulator. And another parameter on which this R value is dependent, it is directly dependent upon the thickness. ठीक है, so this is what they have mentioned here. So is it clear up to this point? Any question?
Sir, इसको फिर थोड़ा explain कर दें.
Okay. There are two materials. मतलब there are certain materials here. ठीक है. On the left hand side, you can see that they have given values of thermal conductivities of different materials. So I am here using iron, ठीक है, or brass, ठीक है. Iron has a thermal conductivity of 67 while brass has a thermal conductivity of 109, ठीक है. So which one has the better thermal resistance, iron or brass?
Iron.
Iron. Is he saying right? Iron की क्यों बेहतर होगी वैल्यू?
सर कंडक्टिविटी उसकी जो है, उसकी कंडक्टिविटी की वैल्यू कम है तो रेजिस्टिविटी की वैल्यू ज्यादा होगी.
ठीक है. So this is all about this equation. अब clear है बेटा? Any question up to this point? बेटा क्लियर है या मजीद कोई चीज पूछनी है?
नहीं सर, क्लियर है.
सर ये जो मार्बल्स होते हैं कुछ जैसे कुछ धूप की वजह से भी गर्म नहीं होते?
हाँ, जैसा जो है बेटा यहाँ पे खाना काबा में ऐसे लगे हुए हैं. they are using they have the marble. मैंने मतलब सुना है, मतलब I never visited. I wish that I could. लेकिन आप में से किसी ने अल्लाह ने आपको अगर ऐसी क्या नेमत से या गुजारा है तो मतलब वाले साहब जाते हैं तो they told me के they use those sort of the marbles that have the poor thermal conductivity. ठीक है. So basically they remain मतलब normal during the summers, ठीक है, and in the winters they again remain normal. ठीक है. So basically अच्छा मैं बेटा फैसल मस्जिद विजिट किया बट नेवर मुझे सर्दियों में विजिट करने का मौका नहीं मिला कि आई डोंट नो व्हाट अबाउट इन द विंटर्स के हाउ दे आर इन द विंटर्स. ठीक है. नॉर्मली इफ वी यूज द मार्बल इन आवर होम्स, so what happens that in the summer they get if they are in the outdoor, they get warmer, while in the winters they get colder. ठीक है? So on the other end, in the Hanakaba, they remain मतलब they are opposite to that of the outer atmosphere. ठीक हो गया बेटा?
Okay, sir.
Okay, चलें. Now coming toward the conduction, ठीक है? Okay, we were talking about the single slab, ठीक है? Okay, हो रही है, सब कुछ है. Now, if we are dealing with the composite slab, so composite slab means that if you are using two different slabs, आपकी 2 बजे क्लास तो नहीं है आज?
सर आज होनी है.
नहीं है. अच्छा, चलें फिर मैं जल्दी से बता देता हूँ बेटा, ठीक है? Okay, if you have एक second बेटा. If you have two slabs here, previously we were discussing about the single slab. Now, right now, here we have two slabs. ठीक है? One is this one, ठीक है, which has a thickness of L2. Other one is the L1. ठीक है? These are the two slabs. So when we use two or three, more than one slabs, then we basically call it as a composite. ठीक है? Even if you are using 2 or 3 materials together, we will basically call it as a composite material. ठीक है? So in composite slab, it means that there are slabs more than one. There are more than one slabs. ठीक है? So here we have two slabs. One is the has a thickness of L1 and thickness of L2. Other one has a thickness of K1 and K2. And again, on the left hand side is attached to a hot reservoir, while right hand side is attached to a cold reservoir. ठीक है? अच्छा, अब यहाँ पे क्या है कि here in this scenario you have to find out the conduction or the steady मतलब rate of transfer of heat. ठीक है? conduction rate क्या है? basically heat transfer per unit time. So again using the equation जो आपने last time use की थी, आप just remember this equation. एक second बेटा. This is the equation here. ठीक है? K TH minus TC over L. This is equation. So here we will use two equations. ठीक है? One will represent the heat transfer from the cold reservoir up to this point, which up to the interface. Interface पे temperature क्या है? TX. And the second from interface to the cold reservoir. So for the first one, ठीक है, first slab which is has a thermal conductivity of K2, so we'll write the conduction rate as K2 area into TH, ठीक है, high temperature minus TX. TX is the interface temperature, यानी on the other end of the temperature, on the left hand side we have TH temperature. On the right hand side of the slab, K2 slab, ठीक है, it is TX. So we will write it like this one, divided by the thickness which is L2. Similarly, the conduction rate for the second slab would be equal to what? K1 into A, because we can see that they have the same area, and then area मतलब देख तो नहीं सकते, लेकिन they mentioned that area is same for both the slabs and they are in contact with each other. And on the right hand side the temperature is TC, so TX minus TC over L1. ठीक है? So क्या होगा कि हम लोग फाइंड आउट कर रहे हैं कि इंटरफेस के ऊपर टेम्परेचर कितना है. So for that purpose we will equate this equation for the TX, मतलब अलजेब्रा यूज करेंगे. TX को हम लोग because both are equal, TX को कॉमन ले लेंगे, and after taking TX common, ठीक है, this equation will come out which is 18.35, and then we will use this equation in any of the 1834. Either we can use in the for the slab 1 or sorry slab 2 or for the slab 1. So this value will be here. ठीक है? And he's saying that if you have the composite material made up of n materials, then this would be like this one, because the only thing that is varying here is the thermal resistance. ठीक है? R value is basically varying. So we are not using the word summation on the numerator. We are using the summation on the denominator. ठीक है? So summation is for R value भी लिख सकते हैं. अगर मैं यहाँ पे simple R लिख दूँ तो in the last मतलब जो इससे just पहले हमने thermal resistance पढ़ा है. So thermal resistance was equal to R was equal to L over K. So I can also write it as a R here. So up to this point clear है? कोई question का मसला हो बेटा? ये सॉल्व आपने करनी है डिटेल में खुद ही, कोई इतनी मुश्किल नहीं है।
मैम
क्लियर है?
सर एक बार ये दोबारा एक्सप्लेन करते हैं, ये TX TC और TH समझ नहीं।
सर मीटिंग एंड करते हैं।
क्या कर दो?
मीटिंग एंड कर दे, टाइम में 1 मिनट से कम रह गया दोबारा।
हाँ चलें ठीक है बेटा, दोबारा ज्वाइन कर लेते हैं, फिर आपको मैं ये बताता हूँ। ओके बेटा, अल्लाह हाफिज।